Today we're going to be doing a review of the Nobsound 6P1 tube amplifier. These little amplifiers are available from different outlets for around $300, and they really are a nice all-tube, no solid state stereo amplifier that gives a good introduction to what tube amplifiers are all about. Unlike some of the other tube amplifiers on the market, this one doesn't have any op amps and isn't what I would consider a fake tube amplifier, as there's no solid state components inside this amplifier. So let's go over the layout of this little amp. It uses tube rectification instead of diodes, using a 5U4C, which is different from the US 5U4 in that it's an indirectly heated rectifier, which provides a slow startup, which makes the tubes last longer. Next are the driver tubes, which are a 6HC6, which is electrically identical to a 6SN7, and they are a direct swap out. So you're free to swap out any of the decades worth of 6SN7 tubes that have been made to roll in a different sound to the amplifier, which is part of the fun of tube amplifiers. The last is the 6P1 tubes, which the amp is named after, which are only made in China and Russia, which limits the selection of tubes that are available for you to use. The amplifier comes with the made in China 6P1 tube, but fortunately the Soviet-made 6P1 P-EV is a very nice sounding tube, is easily available, and really improves the sound quality of this amplifier. I will say that because of the way this amplifier is designed, you need to find matched pairs of output tubes. You don't need all four to be the same, but each pair should be as close to each other as possible. This is a parallel single-ended amplifier. Some people are confused because of the two output tubes on each side that this is a push-pull amp, and it's not. The way this amplifier is wired is the signal comes in through the jacks on the back. It goes through the driver tube, which is wired as a cast-coated, grid leak biased dual triode, which then is sent to these paired output tubes that are wired in parallel as a single-ended amp, which goes to the output transformer and to the speaker jacks. It's wired as an 8 ohm output transformer, and previously some of these were wired with 4 ohm jacks as well. There are some 4 ohm taps on the transformer that you could play with, but then you have to go inside the amplifier. And not only does that void the warranty, these tube amplifiers have lethal voltage inside them of several hundred volts, which can cause your heart to stop if you get shocked by them. So do not mess around inside one of these amplifiers, because the voltage can be stored in the capacitors for a long period of time, up to several days. If you're going to mess around inside this, you need to watch some of the YouTube videos about how to safely work inside tube amplifiers. And if you have any worry about your ability to go inside one of these safely, just don't. This amplifier really only has a couple of what I would call design flaws, and one of them isn't really, to me, a design flaw. It's that the line voltage at the outlet in China is 110 volts, and in the US it's 120. With a solid state amplifier, this isn't a problem because they use voltage regulators inside them, so that anything from 100 volts to 130 volts, and sometimes up to the 240 volts, the regulators pull the voltage down to what the circuit needs safely, and everything's fine. When you have a pure tube amplifier, there is no voltage regulation whatsoever. And if the transformer like this one that's wired for 110 is used at 120 volts, that it increases all the voltages inside the amplifier going to the tubes by that same percentage, which when you're doubling or tripling the voltage via step-up transformer could be 20 or 30 volts more than the circuit was designed for. Most SE amps are designed kind of on the ragged edge of what the tube amperage dissipation or watt dissipation that they can handle is to sound good and to get as many watts as they can out of them. And because of that, if you are overvolting the transformer, many times you're pushing the tubes beyond what they can reliably handle. And I believe that's the case with what we see with some of the negative reviews on this amplifier, being that it eats tubes, or that after playing for several hours, smoke came out of it, or it burned up, or it didn't last very long, is because of this overvolting due to the countries having different line voltages. There is a fairly simple solution to this, and I'll show you a couple of different options that are available for fixing this problem. One of them is this product from APC, which is a voltage regulator, and on the back it has a switch to go from 110 to 120 to 127. So, as you would imagine, if you put the switch on 110, then the output of this box will be 110 volts, which is what this amplifier was designed to run on. This box is about $65, and it would be needed with any of these made in China tube amplifiers that are on the market. So this problem is not unique to just this one product. There is another slightly cheaper solution, which I feel is probably a better solution, but I don't know of any commercially available products that do this. This is more of a DIY solution, and it's called a bucking transformer. And there's plenty of websites online that talk about how to wire up a bucking transformer. I'll link one below. And basically what it does is it's wired in such a way that the voltage that this transformer is rated at, it will either lower or raise the voltage on the output side. So I'm using a Hammond 166N12 12.6 volt 4 amp transformer, which is more than this circuit would really require, but the oversized transformer wasn't much more expensive and should run cooler than one that's rated right at what this amp needs. I wired mine up using an old extension cord and wrapped with tape after I soldered the connections. You need to ensure that you keep the hot, neutral, and ground all connected in the right order through your device to ensure that your amplifier stays safely grounded to avoid any potential for shock. Ideally, you would put this transformer in some sort of an enclosure. I have mine sitting on a bookshelf behind the amplifier. I don't have kids, or it's nowhere that a pet could get to, so I'm not too worried about it being exposed like this. But if you have any concerns, again, there's websites that show how to build these inside enclosures with outlets and all 100% safely wired if you have any of those kind of concerns. The last thing I want to go over is what I consider a design flaw in the power supply circuit of this amplifier. The first capacitor after the rectifier tube is multiple times larger than it should be. It's a 150 UF capacitor, and it shouldn't be any larger than a 33, and a 22 is actually an ideal size for this circuit. Having an oversized capacitor puts extra strain on the rectifier tube, and it also makes it susceptible to the rectifier tube arcing or shorting out when the amp's powered on, especially if it's short cycled. To fix this, you do have to go inside the amp and you have to unsolder and solder in a new capacitor. So if you don't have those skills, or you don't feel like it's safe for you to open up the amplifier, or you just don't want to void the warranty, you can leave that alone. Just be aware that you have to make sure that the amplifier sits turned off for a few minutes before you turn it back on, or it will arc out the rectifier tube and ruin it. The other thing you should be aware of is the output advertised by this amplifier is at pretty high distortion levels that very few people would find tolerable. The way the circuit's designed, once you get over about 5/8 on the volume knob, the distortion definitely is audible. So I would say, as delivered, it's probably a 3-watt amplifier at normal listening quality. Having said that, if you have some efficient speakers like the Klipsch bookshelf speakers I'm using that are rated at 95 decibels, it puts out plenty of volume for a reasonable size room at a high quality level that I think you'll still enjoy. On future YouTube episodes, I'm going to go into some internal modifications that I've done to this amplifier beyond even just the filter capacitor issue that really improve the way the amplifier sounds, as well as recommendations on some driver tubes and other things I've learned from owning this amplifier for almost a year now and experimenting with different things on it. Hope you'll follow up with my other videos and click the subscribe and like if you enjoyed this video. Bye now.